around the world. My name is Sean Moloney. I am publisher of Ship Management International. I'm CEO of Elaborate Communications as well. And welcome to today's webinar, which is hosted by Stream Marine Training in partnership with Ship Management International. We're delighted to be working with our friends here at Stream Marine again. Today, we're looking at one of the fast-moving safety risks facing shipping, fires involving electric vehicles and lithium-ion batteries. Big issue, but this is no longer a future issue. EVs, battery-powered equipment and lithium-ion devices are already being carried on board vessels every day, and the risks are changing quickly. These fires can develop rapidly, behave very differently from conventional fires, and create serious challenges for crews, operators, and emergency response teams. So we're going to be talking about that in today's webinar. And before I introduce the panelists, just to give you all a bit of a heads up, we have quite a lot of people registered today. They're starting to come in. We've got about 170 of you registered. We normally get around about 100 that will come into the room, I guess, at any one time. Just to say to the participants and the delegates coming in, you'll see down the bottom of the page, we have a chat facility down there. There's also a Q&A facility. Can I just ask if you send in any questions, put them in on the chat, and I'll do my best to get them answered for you. And if not, we'll log them all, and then we'll get them answered by the experts separately, and I'll send them on to all of you by email. The webinar today is scheduled to last an hour. I think it's probably going to go over that a little bit. It's a very, very important subject. And also there are a lot of you coming into the webinar today, so I'm sure you'll have certain questions that you want to ask as well. And we have a series of short presentations as well, just to really, really add in more spice. But anyway, so any questions you might have, and also just to say to the panelists, you know, you'll have an opportunity to butt in and to interrupt your fellow panelists. Raise your hand. You've got a raise hand button down the bottom there, or even just do that. A lot easier to do that as well. Anyway, we're very pleased today to be joined today by a panel of industry experts, and you can see them here, who will help us explore the issue from a range of practical, operational and safety perspectives. Our panel includes John Garner of JG Maritime Solutions, Ruud Plomp of Artemis Safety, and Craig Smith and Iain Bonehil from Stream Marine Training. But during the session, we will outline some of the key issues that the industry needs to understand, from the warning signs of battery failure and the importance of early intervention, and going on to the firefighting challenges, onboard equipment options, post-fire risks, and the need for regulation and training to keep pace. This is really, really important. And we hope that today's discussion will bring greater clarity to a complex and rapidly evolving issue, and supports the industry in becoming better prepared for the battery fire risks now facing maritime operations. So before we start, I'm going to ask this excellent collection of experts in front of me to introduce themselves. 2 minutes, folks, if you can do. Just give us a little snapshot on a little introduction as to who you are, what you do at your representative companies, what your companies do, but a little bit of a snapshot on your whole take on this whole issue of electric vehicle fires and the importance of it, and why today's webinar is important. Craig and Iain, let me start with you. Craig, do you want to introduce yourself, and you and Iain, and your thoughts?
Yeah, good morning, everyone. My name's Craig Smith from Stream Marine Training, working in the technical department here at Stream Marine. My background was an engineer on different various types of ships for 16, 17 years. And then about 8 years as superintendent, vessel manager, working between tankers of different types, crude oil tankers, LPG, LNG vessels. And been here at Stream Marine now for 3 years, working technical team, IGF-related courses, training for the future of vessels, alternative fuels, representing companies in their changeover over to these new fuels. Working with fuel awareness and also developing the battery fire awareness, which obviously is one of the reasons we're here today. moving forward, we do see that as a big training gap. People need to be aware of what these batteries are, how they react when they go on fire, and the best way to deal with them. So Stream Marine actively progressing forward with training courses to help owners, clients, seafarers hopefully get the training they require. And over to Iain.
Yep. Hello, everyone. My name's Iain Bonehil. I'm another technical trainer with Stream Marine Training and Stream Marine Technical, as Craig has mentioned. One of our main roles here is the training of personnel, primarily on the IGF code, alternate fueled ships, and latterly now battery-powered vessels. Anything new fuel related. So we are looking primarily at the training of personnel because that is a fundamental point for looking after these new fuels and the safety involved therein. As Craig said, we can provide training for personnel, technical expertise, support and services for all your future fuel needs.
Brilliant. Thank you very much indeed, Iain. So going right to left on my screen, John, do you want to introduce yourself and the company you work for and a little bit about your view on it all?
Okay, thank you. So I'm John Garner. I work my own consultancy company for 8 years now, JG Maritime Solutions Limited. My background is more than 40 years in the industry, 30 years within ferries, and I tended to focus upon ferries. That took me to work with Interferry on the regulatory aspects, and through that I carry out regulatory liaison for them and attend the IMO sessions on SSE, where is the technical aspects of fire protection, and this particular subject comes up. So I'm very much going to talk about the linkage to regulations and the development and the time it takes today. But also, I've recently started managing a company for the Short Straits Maritime cluster. And within that, we just carried out a big training project, a clean maritime training project, which looks at the integrated skills and talent required for the electrification of ferries. And that focuses and hits upon EVs as a subject. So I'll talk about the training, the skills gap that is seen at the moment.
Brilliant, John. Is that DFDS by any chance down there?
No, there's 3 ferry companies down there, DFDS, P&O Ferries and Irish Ferries, but DFDS is within the cluster.
Okay, lovely, thank you. And Ruud, can I ask you to take the microphone and give us a bit of an introduction to yourself, your company, and also what you want to be focusing on?
Yeah, thank you. My English is not as fluent as the previous speaker, so I try to make myself understandable.
Do it in Dutch if you want, Ruud. We can do the whole thing in Dutch, if that's fine.
I will most likely understand, but no, I'm also 40 years in the industry, in the maritime industry. I started studying at the Nautical College in Flushing in 1983. After that, I sailed for a short while on dredging vessels, and I went to the Dutch Fire Academy in 1991. And both the maritime part as well as the firefighting part, I really love to combine those two. So I started working for Risk at the Maasvlakte. And I was mainly responsible for the emergency response team in those days, working for Smit-Tak, and for Wijsmuller, and sometimes also on behalf of P&I clubs. Beside that, I did a lot of investigations. One of my first one was even a car carrier in 1998, so that has been a long time ago. Beside that, I am also advisor to the SOSREP, so an independent service advisor since 1999 or 2000, something like that. And I'm working for, and this is also currently my position during this presentation, as a fire advisor for BlueTack Salvage. And that is a new company based on, let's say, the old Wijsmuller, if I can say so. And last but not least, working as an advisor for the fire department of Rotterdam since 20 years. responsible, or not responsible, advising them on MERC, so Maritime Incident Response Group, on the North Sea. And that's involved in a lot of investigations at the moment, actual fires, so bow carriers, etc.
Really, really well. Thank you very, very much indeed. So that's given us a little bit of a sort of food for thought, really, as we go into the questions. I'm going to start by asking Craig, your little presentation. Are you okay sharing and giving us that presentation? That'd be excellent. And just as while Craig's just sorting himself out on that, saying to the delegates, you know, if you've got any questions, we've got the facility down here for chat. You know, please let us know. We've got Q&A. Actually, some questions are now starting to come in. Good, that's fine. That's fine. But, you know, any questions you have. Now, Anonymous Teddy said we have lots of feedback from one of the open microphones. It seems fine for me. I can hear everybody very clearly. Whether that's just a local issue, I don't know. But if we'll keep an eye on that. Okay, but Craig, over to you, sir.
Yep, you just confirm, Sean, you see the screen okay?
Yep, we can do, yeah.
Excellent, thank you. I will say as well, we've been advised by Sean to keep things short and sweet, so we'll rattle through this as quickly as we can. Now, everyone knows in the news over the last few years, there has been a lot of focus on incidents on vessels carrying EVs, mainly highlighted ones down the left-hand side of the page: Serenity Ace, Felicity Ace, Fremantle Highway, and Morning Midas. Yeah, several vessels carrying EVs suffer serious fires, resulting in significant damage, and in some cases, total loss of the vessel. Company asset has been lost as a result of fires on board. While investigations continue into some incidents, some have reinforced the complexity of managing lithium-ion battery fires in the marine environment. Once the lithium-ion batteries become involved, crews they will face thermal runaway, toxic gas release, and the potential for reignition. In these incidents, they do reinforce the importance of crew awareness, practical preparedness, and effective emergency response. Now, a lot of the investigations into these incidents are still ongoing, and some of them can't even be completed properly because we've lost the vessels. In the incident that has to be taken care of on board. Now, why does it matter? We do see a lot more of EVs across the ships now. There's over 4 or 5 million EVs on UK roads as it is, and we see that number increasing every year. Lithium-ion batteries, they are now commonplace on board, not just on cars. The current guidance, it does continue to evolve. It is at a slow pace. So we need to be aware of all the hazards we have, challenge them as best we can as crew, while they catch up with the regulations. Crew preparedness is becoming increasingly important. Crew need to be aware of the hazards, the signs and symptoms of fires, and the best way to tackle them where possible. The IMO does have a roadmap for the future. I believe John will go into a bit more detail with that, but hopefully within the next few years, we will see the regulations coming through and then changing on vessels, compliance, crew training. But as I said earlier, we are starting to take that by the head and drive it forward. Challenges for crew: early recognition of the incident is key. What's the signs and symptoms of a battery fire on an EV? A safe assessment before intervention. Is it the car on fire itself? Is it the battery fire? Again, recognition of an EV battery on fire. Selecting appropriate firefighting tactics. How do we use the equipment on board the vessels to firefight where possible? Protecting personnel from toxic products or combustion. When the lithium battery goes on fire, the toxic gases produced are extremely harmful to persons on board. So it's the right firefighting equipment, the right BE sets, the right fire suits, and of course afterwards, managing the incident, managing for reignition, but also decontamination of crew, equipment, firefighting suits, and anything used in the incident overall. Now, we all know we've all probably heard of thermal runaway now. Thermal runaway is a self-sustaining chain reaction within a lithium-ion battery that generates heat faster than it can be dissipated, potentially resulting in fire, explosion, and the release of hazardous gases. As I said, we get rapid heat generation. It cannot be dissipated from the battery pack itself. It'll lead to off-gassing, which will release toxic flammable gases. After the fire, you do have a good chance of potential reignition, depending on the state of charge of the battery. If it's got a higher state of charge, the chance of reignition is more likely. Prolonged cooling, the amount of water needed for these fires is considerable, much, much more than it would be for a simple vehicle, which is not battery powered. Operational challenges, detection. Fires may originate in battery packs or enclosed or within enclosed vehicle decks. Early recognition remains critical. Crew need to be doing their best on rounds around the car decks. What's the warning signs? The noise coming from under the car, the popcorn sound, hissing from the battery packs, the vapour being generated and the smoke, and then jet-like flames, things like that need to be understood. Toxic flammable gases, gases like hydrogen fluoride, toluene, hydrogen chloride, hydrogen cyanide. A lot of these gases are extremely toxic. Gas monitoring and ventilation. For crew safety, ventilation, get rid of the gases as much as we can as well. Gas monitoring of the spaces where we have these cars can help in early detection, early indication of something taking place. And for the crew safety, appropriate PPE, risk assessment, and safe approach to the vehicle on fire. Of course, now we're not just looking at cars though. We can see on board the vessels, you've got personal electronic devices, portable radios, battery-powered tools, e-bikes and scooters being carried on ferries, anything within passenger luggage, and of course, back to the battery cars themselves. We have carried out some testing here at our fireground. We've activated thermal runaway within personal devices, a MacBook laptop, the battery banks. We've activated thermal runaway, and we've used a Multimax EX Lithix extinguisher to see what it would do with the fires, and actually it took care of the fire quite nicely. So again, part of the training we've done, part of the information we've put across is from first-hand training on the fireground. We need to understand the fire spread, contain the fire where we can within the vehicle deck, around the car, to stop it spreading to adjacent vehicles and combustible materials. Confined vehicle decks increase escalation potential. Early cooling and boundary protection to stop that spread of heat to start a fire elsewhere. Effective use of fixed and portable firefighting equipment, and continuous monitoring for reignition. We can limit the fire spread and prevent escalation. These are key objectives during any lithium-ion battery incident. If we can contain it, we can stop the spread and hopefully save the vessel, save the asset, and helpfully, and as well, protect the crew on board. During a fire, it is effective in the early stage. We need our crew to know what equipment they have on board. Thermal imaging cameras to highlight the area if it's a car where the heat is rising within the battery pack. Portable cooling devices, you've got a lot of hydro walls, you've got hydro bars, water mist lances to help contain the area. Yes, we've got fire blankets as well. We've got other equipment, but that's just some of them. Operational considerations, early intervention where safe, crew safety, drainage management on decks, and trained personnel. Again, come back to training of personnel to hopefully give them the understanding, the knowledge to be more confident on board vessels. Yeah. Why is training important? Traditional firefighter training provides an excellent foundation, but lithium-ion battery incidents introduce additional hazards that crew should understand. Crew should be aware of and understand the characteristics of EV fires. Detect the early warning signs, as I mentioned, the noises from the car, the gases, the colour of the gases, and respond safely and effectively. Use specialised equipment confidently. There's a lot of equipment out there being highlighted as these will take care of the incidents. We discuss quite a lot of them in the course, go through the pros and the cons, and then not every ship also going to have the same equipment. So that comes down as well to drills. Crew on board need to be aware of the equipment they have and how to use it. I have done a course not that long ago where the company or the persons on the course said they've got a fire blanket. I asked if they've used it and they said it's never came out the container. Unsure best way of handling a blanket that size. Thermal imaging cameras for crew doing rounds on the decks, scanning the cars. Fire blankets and containment equipment. And the post-incident management and the decontamination of equipment and clothing. The equipment should be strategically placed and clearly marked, routinely inspected and tested, the same as every other piece of firefighting equipment on board a ship. Our course now combines a theoretical understanding with practical familiarisation of some firefighting equipment and response techniques. The drills again, if we can simulate EVs on deck, practice boundary cooling and isolation, include reignition monitoring protocols. And I would also add in there as well on drills, the decontamination procedure that should be part of the emergency response. Clear crew roles and communication throughout the incident and the drills. Update your SMS and to reflect EV specific risks. And also not just the EVs, going back to the other equipment which is carried on board, be it laptops, mobile phones, battery banks, anything like that. Even now you've got your battery energy storage systems on some vessels as well. We do have in the future, IMO will come through with their regulations. As I said earlier, it's a slow pace and John will go into more detail, I'm sure. They've got to focus on battery fire safety, crew training and STCW updates, fire detection, suppression and evacuation protocols. Hopefully it doesn't come to evacuation in the future, but we need to understand what that is and the best way around it. For the future, again, we'll reinforce crew training needs to be improved. Practical familiarisation with the equipment on board the vessels. Continued regulatory development, advances in firefighting equipment, improved battery technology. Improved battery technology as well comes down to the cars. Can the cars be improved for the future? Can warning signs come from the car if the battery management system detects a warm battery? Can the car horns start making a sound, flashing lights, anything which helps carry them on board vessels? So it comes down again to knowledge, practical familiarisation, and everybody being prepared. And lastly, just a little bit for us there, our battery fire awareness. We will combine theoretical knowledge and practical response training. Theoretical training, electric vehicles, the battery technology itself, thermal runaway, fire behaviour, current guidance where possible, looking at MCA as a start, and also emergency response planning and operational considerations. Response for the training side, safe approach, selection of equipment and appropriate PPE, firefighting and suppression methods, thermal imaging and battery monitoring techniques, and of course post-management and decontamination procedures. And our address is at the bottom if anybody wants it. We can, of course, if anybody comes to us, we can help develop our course, we can make changes to it for suitable needs of what companies want themselves. And that's us, Sean, just now.
You're muted, Sean.
Thank you very much, Craig. Thanks for the prompt there. If you want to unshare, Craig, then we see that's lovely. Just one question, and I'm going to come on to some of the questions that are coming in from the audience, which is great. And we've already got about 10 questions in there already. What causes a battery to explode? I mean, is it damaged? Is it badly charged? What is it? What starts it in the first place?
Batteries won't ignite themselves. There's been some kind of trauma which is set off the battery, be it an impact, if it's on a road through a collision. It can be overcharging. It can be a short circuit fault through the battery itself. Things like that are usually what escalates it into thermal runaway and then the fire afterwards. Nothing starts itself. It's got to have trauma of some kind.
Right. But one of your early slides, you talked about 4 casualties that had happened as a result of it. Now, these casualties were huge. I mean, they ended up with the vessel sinking and so. Is that always going to happen like that?
Depends how the situation escalates. As I said, if you can take care, isolate the incident, should be able to save the asset. It might not start on an EV, but if it spreads to EVs, you've got a much, much bigger problem. If we can get early intervention, if crew are more aware and more confident of dealing with it, then hopefully we don't get in the same situation where we're losing vessels.
I would add to that traditional fixed firefighting mechanisms on ships are not necessarily designed to deal with EV fires. So as Craig said, we are looking at developing the response systems to make them more suitable and ultimately protect the crew, protect the vessel from total loss.
So do you think not enough has been done from the regulatory side to make sure that ships are actually geared up and in a position to actually protect themselves against such fires?
I think it's a huge area of responsibility, and they naturally have to go slowly. Instigated, as mentioned by Craig, 2027 is a target point, but obviously the sooner the better we get regulations, given the increase in number of EVs on the road and ultimately number of EVs being transported by vessels and in our day-to-day lives, battery-wise.
Now, before we come on to a presentation from Ruud, there's a couple of questions that have come in. Debbie Cavaldoro has asked and actually picked up on one of the points that I was raised my eyebrows at when you talked about the toxic gases, cyanide and all of these very, very poisonous and dangerous gases. But Debbie says, given that toxic gases can be present before any flames or the risk of explosion, is it realistic and safe for seafarers to be encouraged to directly fight EV fires?
That is a good question, and it comes down as well to how you want to tackle. If you've got the correct PPE with your BA set level 2 fire suits, it's a case of do we do something or do we do nothing and hope for the best. Fixed firefighting systems at the minute, as Iain said, is not up to standard for what we need to deal with a large-scale EV incident on board the vessels. So crew should be confident in approaching a fire where possible, using containment systems, using boundary cooling to stop the spread. So sometimes, to an extent, we have to try something, or you might end up getting to the situation where you're abandoning the vessel. And that's, again, because of the hazardous gases, why we discuss on the course the decontamination side afterwards.
Now, Adrian, again on the Q&A, has said no mention yet about vapor cloud explosions or care when venting, major hazard as well. Any thoughts on that?
That comes part of it as well as people originally using fire blankets put the fire blanket over the car. You can trap the vapors inside, flammable, heat, self-sustaining from lithium-ion battery. It can end up in a vapor cloud explosion. Also around the vehicle itself, it can ignite. So crew around the area need to be careful of that, approach it in a safe manner, water walls on the hoses and coming from a safe direction, using cars as barriers to get up close to the fire incident itself.
Okay, all right. Well, thank you very much, Craig and Iain, on that. I'm going to bring in Ruud now, just with your presentation, if I may, Ruud. If you can, we're already sort of halfway through the webinar, strangely. If you can, don't miss out anything, but obviously don't labour a point because we do, time is of the essence as well. But over to you, sir.
Yeah.
Is the presentation visible?
Perfect. Thank you very much. Yeah.
I was planning to do this presentation together with Carl-Henrik Frankman. He is our salvage master. Unfortunately, he had to cancel last minute due to unforeseen circumstances. So I'm trying to answer the 4 questions as good as possible. I'm not a salvage master. I'm a mariner, but I know a little bit about ships, not and firefighting a lot. So the questions that we would like to go through is how fires, EV fires, battery fires do change salvage operations, whether they are different challenges. Then, of course, something about the impact on the towage and the casualty management, and then something about what we can do for the near future, how we can prepare it maybe in a different way. So what we should evolve, these kind of things. First of all, I would like to take you back to 1998. We had a car carrier on fire somewhere in the Middle East. The name of the ship was the Eurasian Dream. The problems that we faced actually was that, and that's nothing new, and everyone who has been on a car carrier knows what I'm saying. Very long interrupted vehicle decks. The cars parked very close to each other. Limited access for crew and salvors. Rapid horizontal fire spread. A lot of smoke, so reducing visibility. Maintaining the ship stability is always, of course, something you have to keep in mind. And because the operations are internal and last for a quite long time, you have to think about fatigue. And of course, but that's within every salvage operation, pay attention to command and control between the ship's crew, if they can still stay on board, the salvors, and maybe some other parts like Coast Guard, etc., depending on where the ship is situated. So I think that in general, the challenges didn't change that much in general, I have to say. Of course, EVs make it more difficult. So extinguishment of the fire becomes more difficult. You need a prolonged cooling. Monitoring becomes more important. And we always have to keep in mind that we have reignition possibilities. Now, we all know this one, the Fremantle Highway 2023. I was partly involved from the fire department's perspective, so the MERC teams. And I was also involved in the investigation. And one of the things is that it took quite a long time before we actually knew how many EVs were on board. So if you have to respond, you don't have the actual information about the cargo, it also becomes a little bit more difficult to make a good and a proper risk assessment. We started only, I believe, with 5 cars. Later, they turned out to be 500. Then a little bit later, we had the Delphine in Zeebrugge. And over here, you see the pictures on the right side, the car decks. There's a little bit more space between the cars, but there were also less cars on board. And we had immediately 4 tugs available for boundary cooling, or at least the port authorities did have those available. How do EV batteries change salvage operation? I'm not going through everything on this slide. It's more a little bit of a background information. Some of the things already have been discussed by Craig as well. We have the thermal runaway reactions. We have what Adrian also said, the possibilities for explosions. You always have to keep in mind that fire suppression is always difficult because we have long longitudinal decks, only a limited transfer bulkheads, and we have a fire suppression system, whether that's CO2, whether that is a drenching system or maybe even foam. It's still difficult to control the fire, and it's more or less a suppression and not a firefighting system, of course. Then the question is the crew capable of fighting those fires? And if we look at what happened at the Eurasian Dream, it all depends on the response time. So whether the fire is detected in a very early stage. And in the Eurasian Dream, it took quite a long time. So in fact, the crew had no chance to fight the fire. So then the only thing is hope for the best. Hope that the suppression system will do its work, and that you maybe sometimes need to also have a little bit of luck that fire will not spread to other decks. Then, of course, the boundary cooling itself, it's always good to see that there are tugs close to the ship, but actually it will have almost no influence on the fire in the ship itself. So it's more the protection of the ship's hull, and it is of course a little bit limiting the how do you call that, the heat transfer via the bulkheads. The second one, and that has already also partly been discussed by Craig in the previous presentation, the fire in EV cars, and especially maybe not everybody is aware of that. We did quite some tests in the Netherlands, as well as, of course, in other countries, the high-risk cars are not the 100% EVs, but are the hybrid cars. So a combination between the ICE, the combustion engine, and a battery. Especially because it's difficult to access the batteries. They are somewhere down in the car. So a drenching system or a carbon dioxide system will not actually fight the fire. It will only have limit the chance that it will spread. Of course, we have thought about blankets. We have thought about a Cobra system, so to penetrate. But it all turns out there are only limited solutions, especially because we're not talking about maybe one car, but we're talking about multiple cars that are on fire. Then already discussed the toxic gases and the limited visibility. So maybe you have to think about different PPE, both for the crew as well as for salvors, the firefighters, and maybe onshore firefighters, if they would board the vessel. And water management was and is still a serious challenge. The impact on the towage and the casualty management, and this is not my expertise, of course, but I think the most important thing is that whether you are towing a vessel or not, that doesn't differ that much, whether it's a conventional ship with ICE cars or whether with EV cars. I think the most challenging part is if you find a port of refuge or place of refuge, to discharge the cargoes from the car carrier. So it's whether in the old situation you just took the car off, and now we have to make this whole decontamination process, which makes it, of course, more difficult to get the cars off the ship and also to transport them from the quayside to a yard where you can deal with the wrecks. Last but not least, what the industry must or can do to prepare, and what the salvage industry can do to prepare. And I think some of these issues already have been discussed. I think it's very important that we learn as much as possible from recent or let's say past casualties. I think that was also a discussion that we had with the Stena line, that it improved detection and monitoring. That is so important. The faster you can monitor a fire, the faster you can respond, the more chance that you will have to control it. So I think that this is maybe with cameras, with all kind of measuring equipment, that's an important part of it. Of course, also crew training, and especially also what they can't do, because I think although they have an advanced firefighting training, they are no professional firefighters, so they are limited in their response. And I always say it's better to stay safe on board than to go to fight a fire if you are not sure whether you are able to manage it. Cargo information, of course, that we know how many EVs, how many hybrids, and how many ICE cars are on board, where they are loaded. And maybe think about new technologies, about fire suppression systems. Then salvage industry, and I think that is all the preparation. So if we are dealing with a car carrier on fire, we can think about developing specific procedures, both when the ship is still offshore and when the ship is entering a port. And of course also, and that's one of my key issues, always strengthening the cooperation with all the stakeholders involved. I think that's very important. You can already start before a you have a car carrier on fire. So invest in cooperation. Last but not least, and this is just my statement, I think when I compare, for example, the Eurasian Dream in 1998 with the Fremantle Highway in 2023, so that's 25 years, that the outcome of a EV fire or a car fire on a car carrier is determined less by the ignition source than by whether the fire can be prevented from escalating. The only thing is that the challenge, of course, is different because of the battery packs. Lithium-ion batteries make that window for successful intervention smaller and the consequences of missing it greater. So that's the reason why I said we have to invest in monitoring and detection. but they do not fundamentally change the operational nature of shipboard firefighting and salvage. So that is my let's say my last conclusion, because we still have let's say the challenges that we always had. The only thing is that we got this this additional risk of EV. I hope this was a bit understandable.
Thank you, Ruud. That's brilliant. And actually, your point there that you just finished on there, we've got a question from Ohad Orbach, who said one of the key problems is detection on time, because sometimes the fire doesn't start at the EV but spreads to it.
Yeah.
What are your thoughts on that? Because as you said, as I think where we heard from Craig, you know, the onboard crew are going to be more vigilant, going on the car decks, checking hissing sounds, all the rest of it. But when you've got 8,000 cars on board a car carrier, how are you going to pick up everything? So what are your thoughts on this whole issue? Very important issue of detection.
Yeah, that's a very difficult one. Yeah, the observation rounds become important, of course. You can also work with fixed cameras or CCTV cameras with thermal imaging, these kind of things. But yeah, it's a challenge. So far, I have not heard about a perfect system that works in every situation. And of course, if you have bad weather, you're not sending your crew members on the car decks as well. So it also depends on the circumstances. So I think the more you can do by cameras and let's say remote sensing systems, the better and the safer it is.
I mean, Paul Coates, some excellent questions coming through here. Has said that crew need to activate fixed installations as soon as they can to help contain. He said, the picture with a BA crew with a fire extinguisher does not take into account how large the EV fire will be by the time they've mustered and got into action. He said, I was on the Fremantle Highway for 6 months doing fire investigation. Multiple cars were on fire by the time the crew investigated. Yeah, what are your thoughts on that? I mean, this is right, isn't it? I mean, these things spread, and
I'm sorry, I did not completely understand the question.
I'm just saying about how by the time the crew mustered and got themselves sorted out, fires massively spread.
Yeah.
And how can that situation be tackled?
I think if I understand rightly, I'm sorry, maybe I give the wrong answers to this question.
No,
I think the main problem is that as soon as you have detected the fire, you have activated your suppression system without being able to go to the car deck, whether it's safe or not. You can't do much more. You go to your muster station and you hope that the fire will be controlled by the suppression system, and that you don't have to leave the vessel.
And okay, well, one question I've got here actually, Ruud. When you talk about the mistakes that people make when responding to lithium-ion battery fire, what would you say are the sort of main mistakes that are sometimes made when they're responding to that type of incident?
And what kind of mistakes are we talking about?
When they're responding to lithium-ion battery fire rather than any other fire. I mean, it's down to training. We've talked about it all being down to training, but are there? Do you come across certain mistakes that crews are making, and maybe bring in Craig on this as well? Are there certain mistakes that maybe crew are making on board when they're faced with a battery fire?
I think mainly it comes back to basic knowledge and awareness. And I think that because they are less predictable than normal ice cars, that you always have to keep that safety margin in mind. So not responding, I think that everybody can afterwards explain why they didn't do a personal intervention. And I think there are many sailors have lost their lives because they actually wanted to do something because they thought they had to, instead of saying, okay, this is out of my league. I'm not responding at all. And I know this is maybe not the answer that people want to hear, but to my opinion, going through a basic firefighting course and an advanced firefighting course every 5 years doesn't make you a firefighter.
That's right.
No, and also, Ruud, you're exactly right. We've had that situation in things like enclosed spaces on board ship, where somebody, a seafarer, has got into trouble, got into a tank, has then become unconscious because there are toxic fumes in there and is close to dying, and his colleagues go straight in after him. You don't do that.
Exactly.
You go away, you then kit up, you protect yourself, and then you go in. So you end up having 2 or 3 people dying as opposed to, one sad person, but then the whole situation being managed correctly. Craig, have you got any comments on that at all? Or
I would just add in as well that we know traditional firefighting is different than what we need for EVs. We know a lot of the fixed suppression systems on vessels are not up to standard for EVs.
Mm-hmm.
So it comes down to a case of do something or do nothing. If the standard fixed firefighting systems can buy you a bit of time to get the crew on site, get them prepped, get them ready to tackle, it might get you some time before you end up in a position of leaving the vessel. Because we always say there's no better lifeboat than your ship itself. So having been on a ship years ago that went on fire and we had to evacuate through helicopter, doing nothing to me also isn't always a good idea.
Craig, before I go on to John to hear his presentation, there's a question that's come in saying, did Stream Marine create any battery Leon fire on board at your SMT training site? Did you actually recreate a battery fire?
We've activated personal devices like the laptop, battery banks. We've set them off and used the lithium extinguishers, which was a firefighter with the extinguisher. That was part of the training at the site with a manufacturer who's developing these extinguishers. What we're doing just now at the site is we've got a car as a mock station. We've got some equipment to get crew, to get anyone who wants to come do the training up close to a car on fire with some of the types of equipment available to get them as a hands-on experience and approaching and finding out the safe ways of hopefully trying to suppress a fire. Using the word extinguish is a difficult one for EVs. Always for me it comes down to suppression. Stop the spread and contain it where possible.
Okay, lovely, thank you. So John, I think it's probably over to you for your presentation again. And again, just while John's getting himself sorted out, just want to say thank you to the delegates who are putting in some good questions there. So thank you very much for your efforts there. But John, over to you.
Yes, thank you very much. So can you see the first slide there?
Yeah, that's all good. Thank you.
That's all good. Okay, so just to move on, these are the fire scenarios of ships that we've seen last couple of years. The trend is that there've been all car carriers and there've been total constructive losses. And how do we deal with that? So addressing the compliance gaps, it's the SSE subcommittee at IMO that deals with this. So there is this emerging roadmap, which I talked about last time, which is now updated. And basically, there is a continuation of the correspondence group and working group on new energy vehicles. And by early 28, they will finalize interim guidelines. And then they will get approved later at the MSC sessions of IMO. But it's only by 2032 we see a full amendment in the SOLAS. But the interim guidelines allow people to implement, gain experience, and then further update prior to putting the final touches to the SOLAS amendments. Just looking here about fires on ro-ro decks, it happens all the time, and Interferry actively takes part in this subcommittee at IMO. And the most relevant issue that Interferry have come across in these subcommittees last couple of years is that there's sort of it's discussed as ro-ro space fires in general, but we've actually got 3 different ship types here: ro-ro passenger ships, ro-ro cargo ships, and ro-ro vehicle carriers, PCTC. All right, and the risks are different within the ships, those 3 ship types. the fire detection, the fire protection, and the fire extinguishing is different. So therefore, they have to be considered differently. The main difference, of course, between RoPax and Ro-Ro cargo ships, they use water drencher systems, whereas vehicle carriers use CO2. The problem with CO2 is the master has got to carry out a muster to absolutely categorically confirm all seafarers are out of the cargo spaces before he will put in CO2, and therein comes a delay. In the subcommittee meeting in March this year, it was agreed that EV fires in vehicle carriers, meaning car carriers, pure car and truck carriers, was the most pressing issue. Those guidelines, as I said, be ready by 2028. If these findings are relevant to RoPax and Ro-Ro vessels, then the amendments and recommendations found for vehicle carriers will be considered for the Ro-Ro and RoPax carriers as well. This is just looking at the different rules and requirements. The resolution MSC 30 was really the revision of SOLAS Chapter 2.2 that went on through that same group. New Regulation 20, and things have come into force for new ships constructed after 1st of January 2026, and for existing ships first survey after 2028. And that relates to fire detection, video monitoring, structural fire protection, etc. I won't go into that too much now because we've been into that before. There are the new interim guidelines expected mid-2028. And I'd just like to go into further information coming from Lloyd's Register Class Society with a vessel notation EV and EV Lite, EVL. So a lot of text on here, don't worry about that. But basically, the notation of fire and EV notation would give supplementary fire safety measures above statutory requirements for prevention, detection, and firefighting capabilities. And this notation has now been agreed, and it's gone into Lloyd's Register rule set in the first quarter of this year. So when we look at the fire EV, the various hazards, the proposal of the notation is to address potential fires originating from or reaching EVs. Key hazard is fires originating from lithium-ion batteries installed in EVs, and fires originating from lithium-ion batteries can release toxic and corrosive gases, very harmful to the persons on board and pose risk to the environment. So the mitigations proposed are fire detection, structural fire protection, ventilation suppression, firefighting equipment and systems. Just to look at that in a bit more detail across the three ship types then. So these are within the notation, fire detection system, all Ro-Ro spaces, minimum 2 types of fire detectors, 1 flame, the others to be smoke or heat. The flame is a new introduction. So that is in place except for flame on RoPax, but Ro-Ro and car carriers, it's not in place pre-2026 ships. A colour video monitoring system. For RoPax ships, this is in place now, Regulation 20, except for the colour. It has to be an effective video monitoring system. Fire patrolling, fire routes to be covered. Yes, that's in place. It's not specific to EVs, but that is a management role on board to determine what the fire patrol route should be, taking account of EVs. Structural fire protection, additional to statutory requirements, ensure integrity of survival craft, escape routes, etc. Discussed a lot within the previous SOLAS amendments. It is, yes, for new vessels of RoPax, governed by the Regulation 9, not in place for the other 2 ship types. Ventilation systems serving Ro-Ro and vehicle spaces, independent, entirely separate from other ventilations, yes, in place for all 3 ship types. Firefighters' outfits, it was mentioned about the toxic gases and somebody mentioned a level 2 firefighter outfit over and above a higher standard than what is mandated today on board for those that we have lithium-ion batteries and these type of fires on board. So the operators have put that in place, mainly with regard to RoPax ships. Additional measures: open deck. This is weather decks protected by at least 2 dedicated water monitors. That's in place for RoPax, the new Regulation 20. What you can see on those columns is RoPax far more mitigation measures in place than Ro-Ro cargo ships or car carrier cargo ships, reflecting perhaps the higher level of passenger ships. Just continuing the last few items: fixed fire extinguishing systems, a fixed pressure water-based fire system to be provided in the designated area where EVs are stowed. Yes, that is the case for RoPax and existing ships. Ro-Ro, yes. For car carriers, no. Additional measures: alternative arrangements such as we mentioned, water curtains, water mist lances, fire blankets. Yep, that's in place by RoPax operators, recognizing the risk. So in summary, this class notation, the ones I've been through are for the EV, basically full notation. Within the EV light is included is fire detection, video monitoring, fire patrolling, firefighters outfit, and additional measures. But excluded is structural fire protection, ventilation, and I think importantly, fixed fire extinguishing systems. So there's no requirement to put on a car carrier a fixed pressure water-based spray system in place. And there are people building new car carriers today coming out of Japan and China with just CO2 fire extinguishing medium on board, which needs perhaps some reflection. Also, it was mentioned about the STCW. The ongoing review of STCW identified 416 gaps. The last session addressed chapter 1 and 2. There are some specific gap number 277, add requirements on the ability of seafarers on Ro-Ro passenger ships to cope with fires caused by new energy vehicles. That hasn't been dealt with. I think that will be dealt with when we get to chapter 6. And gap number 325, add KUP, the competence, understanding, proficiency for competence to control firefighting operations aboard ships after firefighting involving dangerous goods. It may be added electric vehicles with lithium-ion batteries and batteries with similar risks. So there is some STCW work to be done there. Just want to address a comment from Craig, because the industry position and Interferry have promulgated this far and wide, is that no higher risk of fire from e-cars, electric vehicle cars, compared to any other vehicle. However, they are different. And what was proven through the Lashfire project, and a paper was written to IMO and it was presented to IMO, is the ability of the existing drencher systems on board Ro-Ro passenger ships, capability to suppress the fires from electric vehicles. There's guidance in various publications. I won't go through it now, just in the interest of time. But what should the industry do to prepare then? Effective manual operations, realistic drills was mentioned, ignition prevention, screening and management of fire hazards, detection. Early detection is absolutely key. That early detection and then the action to get on the fixed water-based systems. Now, the international group have done work on this, and if you're mustering everybody and sending a runner to have a look, you've lost it already, because that would take up to 20 minutes. And the guidance is, if you need to have the fixed system working and on within 10 to 12 minutes, and that's been proven by a fire on board a Stena RoPax ships when the fire was controlled when they activated early. Containment, smart use of Ro-Ro deck ventilation in the early advent of fires can help. practical use of water curtains. So in summary, what do you need? Well-trained, familiarized, well-drilled crews, knowledge of EV-specific hazards, knowledge of the firefighting management, supported through risk assessment training, proactive safety management, anticipating emerging compliance standards to meet the challenges of carrying battery electric vehicles on board. And as ever, people on board have to work together as a team. They're not firefighters, but we need to ensure as an industry, everybody goes home safely. Just the last part, I wanted to introduce this integrated skills and training project, which has been run by the Straits Maritime Cluster. This is a schematic of the Port of Dover, and very clearly the skills that we've had in place through STCW for the requirements of low pressure, heavy fuel and marine diesel oil systems are not the skills that we need for tomorrow, where we talk about high voltage systems in ports for electrification and or high pressure alternative fuels such as ammonia and hydrogen. The example here is about electrification. So just very quickly, grid and power systems, high voltage. There is traditional roles there, civil engineers, construction engineers, but digital twins at the bottom and asset optimization, use of robotic, shore power armed, naval architects assisting with retrofit and development of new ships and project management. And just what came from this, which is relevant to this discussion, is from the findings, it was found there was a critical lack of physical high voltage switchgear simulators and lithium-ion fire training grounds available. They also found what they call instructor lag, as current trainers may, in their experience from the area that they looked at, primarily retired diesel mechanical mariners who may not have had high voltage or BES experience. And that was based on an audit of 3 training institutions, which they carried out in this project. So lastly, extract from the recommendations, secure CapEx for training infrastructure for BES thermal runaway training grounds, establish OEM partnerships and instructor secondments, and establish, cross-border regulatory harmonization between UK and France. So there's recognition of the training, the competence and the certification. And that, ladies and gentlemen, completes the presentation.
Thank you very much, John. Very, very comprehensive. We've had a couple of questions that have come in. Are there any vessels that have obtained Lloyd's Register's EV-related notation? If so, could you please share any examples? Are you aware of them?
I did ask Lloyd's this when I met them about a month ago, and it was one of the senior managers. They'd been traveling, so they hadn't caught up with the status back at the office. So I don't know that the answer to that question at the moment, but I will find out.
Okay. And if fixed fire extinguishing systems are not considered effective, and we saw that in your slide, against EV fires, what's the benefit of activating them at an early stage? Would this not prevent the crew from carrying out manual firefighting actions that may be necessary to control an EV fire? We'd appreciate your views on the balance between early manual intervention and activation of fixed fire extinguishing systems. What are your thoughts?
Yeah, I mean, what my slide said was that there is confidence in the drencher systems fitted within ro-ro passenger ships and ro-ro cargo ships because they've been tested with EV fires in fire grounds through the last fire project. Early intervention is key. If it's a small fire scenario, then there may be an opportunity, but when we talk about EVs, we've got the toxic gases, we've got other things that are coming to play. So what we've seen to be the strategies that have been adopted is early detection, operation of fixed extinguishing systems early. That can be supplemented by boundary cooling used by the crew from the water monitors that we've now seen being installed on RoPax ships and through boundary cooling from a distance. So there is opportunity to supplement fixed systems.
And maybe just one for you or for Ruud. Adrian has said, don't forget foam, Morning, Midas and Fremantle Highway with foam suppression systems. Foam good?
Yeah. I mean, yes, a lot of the Japanese car carriers have foam installed as a supplementary system to the mandated CO2 system. So that basically, when it's activated, it's like a wall of foam, goes across the vehicle deck. So it has had its places, and it's supported by the Japanese administration and the Japanese industry.
Brilliant. Okay, John, if you can unshare your screen, that'd be brilliant. We were sort of over time really here. Any questions from the panelists on what you've been hearing from John, or any observations that you want to sort of raise? We've covered a lot of ground here today. Craig, are you anything that you want to raise, or that you want to particularly maybe talk with as far as John's presentation is concerned?
No, not so much, Sean. We're happy enough here that, again, if anyone wants help training or anything, please let us know. We can change, we can accommodate what people want quite easily for us. With the equipment we're getting, the equipment we've got, we can go through a lot of stuff on the fire ground as well as the theoretical side.
I would just quickly add on to that, Sean, that he did mention the water walls in the presentation. We have got them on site and we've seen them. And as someone who's never seen them before, they are extremely effective. So there is some good technology out there, and demonstration of that technology is going to be important in future training.
Well, I'd like to carry on in.
John, it's me. Just coming back to answer a question from Paul Coates about lash fire. Tests were mainly outside, did not reflect what would happen on a car deck.
Yeah.
Tests were outside at Gihon Firegrounds, but tests were also carried out by RISE inside, reflecting the exact same fire test mandated by SOLAS for the testing of fixed extinguishing systems, and that was proven. Okay,
thank you very much indeed, John. Well, I want to thank the panelists today for your excellent presentation. We've had one delegate saying exactly the same. I think you've hit a note there with the delegates today. Very, very well presented. Incredibly interesting and important subject matter, and one that I think we'll have to continue to have these sort of webinars moving forward as things develop. I'd also like to thank the participants coming in. It's actually quite nice to see good numbers coming in and good numbers staying throughout the whole webinar. And that's been excellent. And thank you very much for your questions. Just to reiterate, today's webinar will be edited down for brevity, and then will be hosted on the shipmanagementinternational.com website, where you and your colleagues, whoever you may be, listening in, can then download and listen at your leisure. And any questions you have, please email into the shipmanagementinternational.com, and we'll pass it on to the panelists as well. But thank you very much indeed, again, for your time today, panelists. And thank you, Stream Marine, for your efforts in helping to put together today's webinar. These webinars are very, very important. We cover these subjects and these issues from a very objective standpoint, and actually tapping into the knowledge and expertise of people like Craig, Iain, John, and Ruud is invaluable. So thank you very much indeed. And ladies and gentlemen listening in, thank you very much for your time. So, gentlemen, thank you very much, and look forward to seeing you again soon.
Thank you. Thank you.
Yeah, thanks a lot.